Okay, let's continue. Now, when you move the delta T min to bigger value, larger value, you'll see the difference for QH min and QC min, and also the heat recovery. Okay. So if you set the delta T min a larger value, you will have a heat recovery, less of heat recovery. Now you need to supply more of the heat. Then you need to supply more cooling utilities. Okay, in order to achieve your target temperature. Okay. And the pinch temperature, see, is there any difference? Pinch temperature, if delta T min is 10 degrees C, what is the hot pinch over here? We refer as hot pinch. What is the hot pinch? What is the hot pinch temperature? Around 90. Is it? Okay, let's say if you increase the delta T min, then the hot pinch will be different now. Okay. Okay, now to conclude on the composite curve diagram, we have, once we identify the pinch point, so we have area above the pinch. Okay, here is above the pinch. Here is below the pinch. Okay, so what happened? Above the pinch, process is in heat balance with minimum hot utility. So above, balance with the hot utility. Below, with the cooling utility. Okay, so the above act as heat sink. Heat is received from hot utility. Okay, heat is received from the hot utility because you supply some amount of hot utility. So the heat comes, the original heat comes from the utility, hot utility. Okay, now for the below pinch, related to the QC min, okay, no heat is received, but heat is rejected to cold utility. The process acts as heat source. Okay, heat source. So make sure you know the difference between above the pinch and below the pinch. Okay, there are two areas over there. Okay, then the next slide here, it shows the possible heat transfer. Okay, the possible heat transfer flow. You see from here, from above to below pinch. Okay, the heat transfer from above to below pinch. Above to below. Okay, from hot, here we supply the hot utility. So that's how the heat transferred from the above to below pinch. Below to above is not possible because here we supply the cooling utility. Okay. Okay, now for the process flow sheet, quite small over here. Okay, process flow sheet, it is difficult and complicated to see the heat integration network because it involves the unit of everything. Usually for the heat integration network, we will use the heat diagram, sorry, the grid diagram, to show only the heat transfer operation over here. Okay, so do it stream by stream, hot stream and cold streams. H is always used for hot, C for cold. Okay, so divide the process into two parts using the pinch. No transfer of heat across the pinch. Okay, either process to process or through inappropriate use of utilities. Again, the transfer from above to below the pinch. Okay. Now, I emphasize the process flow sheet over here, how it transferred to the grid diagram. This is the process flow sheet with the unit of involved. Okay. Now, hot stream and cold stream. First thing first, you need to identify which stream is hot, which stream is cold. Okay. Now, for feed 1, wait, I use highlighter. For feed 1, hot or cold stream? The green color. Hot or cold stream? Cold. Increase temperature. Okay, cold, huh? For feed 2, from here and okay, from here to here. Hot or cold? This one hot. This one? Feed 2, hot or cold? 140 to 181. Sorry, this one is cold. Cold, right? Feed 1 is hot or cold? Cold. Increase temperature. Feed 2, cold as well. Okay, now feed 2, this cold stream, I take from 140 to 181. T supply, T target. Okay. Moving forward, the temperature is still increasing. Right, until 230 here, before it enters the reactor. Right. Agree? Okay, so now this cold stream reflected with this grid diagram. The feed 1 is this one, feed 1, from 20 degrees C to 180. Cold stream. Okay, the cold stream, the second cold stream is this one, from 140 to 230. Okay, for cold stream 1, feed 1, how many heat utilities that you can see? C1, how many heat utilities? Heat utilities. Or cold utilities. Heat or cold utilities. 3. heat or cold utilities. 1. C1 at C1. 0. Keyword is utilities. 1, 0, 3, 0. The point here, this is not utility supply. This is the heat exchange between the streams, between the hot streams. Utilities mean you need to supply. Okay. At C1, there is no heat supply. They exchange between the stream. Okay. This one falls under the Q recovery area. From the composite curve, it falls under the Q recovery area. They exchange heat. Okay. C3, 1 utilities, hot utilities. Okay, here you can see it clearly. This is hot. H is hot, hot utilities. Okay, get it? How to read the diagram? Now we move to hot stream. Okay, hot stream, let's say. Coming out from the reactor. 250. Okay, this is one of the hot stream. From 250 to 40. Effluent from the reactor. Another one is after reactor 2. Hot stream. Okay, so from 200 to 80 degrees C. Hot stream. Okay, this is hot. This one is also hot. T supply for the effluent from reactor 1. T supply is 250. T target is 40. Okay, from effluent reactor 2, T supply is 200. T target is 80. 80 degrees C, not 80 degree over there. Okay. Now, H2. Okay, label as 2. Any utilities that you can see? How many? 1. Okay, 1 utilities. 1 cold utilities being supplied. The rest means exchange the heat. Okay, they exchange the heat. Now, H4, any utilities being supplied. Does this? No. Okay, so for H4, this stream, let me highlight. Okay, H4 here, there is no utilities being supplied. The point here is the heat exchange. Occurred the heat exchange. Okay. Okay, so if I just give you a PFD with streams and temperatures, now you can identify which is hot, which is cold. Okay, most of the exercise it already identify for you which is hot and cold. So if I give the PFD, you should be able to identify already which stream is hot, which stream is cold. Okay. Any questions so far? Okay. Now I move to the next one. For the composite curve, we can obtain the energy. Okay. Okay, but it is limited to only few streams. Yes, you can draw it manually, plot the graph, but if it involves many streams like your PDP, how you want to do the composite curve? Okay, it's not possible, right? That's where the PTA comes in. Okay, the PTA, an algorithm known as problem table algorithm to calculate the pinch temperature and also the energy target. Okay, this one you don't need a specific graph paper. Okay, you can use Excel, but during exam, of course, you need the paper. Okay, you still need to know how to calculate, how to relate it. Okay, now we go step by step. The principle of the PTA. Okay, in PTA, previously in composite curve, we use TS and TT. TS, T supply, and TT. Okay, we play around to these two temperature only. Now, for the PTA, we will have temperature shifted. Temperature shifted. It will be denoted as TS star, TT star. Okay, when you see star, means this is a shifted temperature. Okay. Now here, let me make it bigger. Why we need to shift? Okay, we have delta T min. We already identified the delta T min. So for the shifting, usually the delta T min will be divided into 2. Okay, the purpose of construction, the hot composite is shifted to delta T min over 2, colder than it is. Then the cold composite shifted to this, divide by 2. The delta T min divide by 2. Okay, they shifted because, okay, you see the hot temperature, the hot stream here, the red one, not the dotted line, this one. Not the dashes one. Okay, this is the original hot stream. The dotted line is the shifted temperature stream. Okay, so hot stream, the TS, the TS or TT minus this one, minus this one. Hot stream, the T minus delta T min over 2. We shift down. The hot stream, we shift down. The cold stream, we shift up. So cold stream will be plus the delta T min over 2. Okay, because we want to close the gap at the pinch temperature over here. When you shift, the cold shifted and the hot shifted will meet at this point. Okay, will meet at this point, at the pinch. So we will see the horizontal delta H, horizontally, how they being distributed. Okay, this part, it being highlighted to here. Okay, that's why we shift. Okay, later we go do exercise, then you understand more. Now you need to understand the terms and why it need to shift. Okay, the shift here, it already highlighted over here. The shift simply removes the problem of ensuring temperature feasibility within the temperature intervals. Okay, it removes so that it ensures the feasibility of the interval. Okay, and then the shifting technique can be used to develop a strategy to calculate the energy targets without having to construct the composite curve. Okay. Now for PTA, we need to shift the temperature, either adding or subtract. Hot minus cold plus. Okay. Now this is the step on developing the PTA. First is to set the shifted temperature from the original stream. Okay, as I mentioned, hot stream, subtract, cold stream, add. Next step is to calculate the energy balance in shifted temperature interval. The delta H in the shifted interval. Okay, where it is the summation of CP cold stream minus CP hot stream. Okay, the summation. Why summation? Later on, you'll see you will have an overlap, let's say from cold stream to hot stream. So in this area, you'll see overlap of hot stream and cold stream. So they are having different CPs. You must sum up all the CPs within the area. Okay, CPs within the area. Then multiply with delta T. Delta T here is you will have let's say here you have a temperature beside. Let's say 180, 140. This temperature is set based on your shift temperature. It is not like plotting a graph. You have a scale. You have specific. You have set the specific scale. No, it depends to the temperature, the shifted temperature later on. Okay, we see. Now the delta T here is between these two temperatures. So here it will be 40. For example, delta T will be 40. Okay, this is not fixed. It depends to the temperature. Then third step is to cascade the heat down the temperature interval. Provide external hot utility if needed. Okay. Okay, we go one by one. Let me know if you don't understand and ask questions. Now this is again back using the previous data in slide 17. Here it gives you TS, TT, delta H, and CP. Okay, just now, first step is to determine the shifted temperature. First, determine the shifted temperature. From the given actual temperature, TS and TT, you find the T star, the shifted. Okay, for stream just now, we add delta mean divided by 2. In this case, delta T mean equals to 10. Okay, so delta T mean over 2, it will be 5 lah. Okay, now TS, full, at 5. So you see here, TS star will become 25. T target, 185. Given. It will be given. Delta T mean usually will be given. Minimum allowable temperature difference. Okay. Now, see for hot stream, shifted temperature minus 5. 245, 35. Okay, same goes for the rest of cold and hot. Cold at 5, hot minus 5. Okay, the amount of 5 there, it depends to your delta T min. Okay. Up to there, any question? Can follow? Okay, now, once you determine the shifted temperature, second step is to what? Calculate energy balance in each shifted temperature intervals. Calculate energy balance. Okay, in here it doesn't show. Let's see if the next slide shows. Okay, I don't want to proceed with the heat cascade yet. We go step by step. Next step is to calculate the energy balance. Wait. Okay, here. Wait, sorry, I go to the previous slide first. Yeah, my PowerPoint is not working well. Okay, let's not focus on the heat cascade yet. Now I want to highlight on the temperature. How you want to see the delta T. Yeah. Okay. Now from here, shifted temperature, you have lowest is 25, highest is 245. Right. Then arrange accordingly. Arrange in order, in decreasing order. From top 245. Okay, 245 here. Then going down 235. Okay. Moving down 195. Okay, 195. Then 185. Okay, 185. Then 145. Okay. Then 75, 35, and 25. Okay, arrange them decreasing order. Higher to low. From high temperature to low temperature. Okay, up to that. This is what I meant. The range, the scale of the temperature here is depending to your shift temperature, the shifted temperature. You see from 245 to 235, what is the delta T? 245 to 235, what is the delta T? 10. Okay, that is delta T for that area. 235 to 195, the second area. Okay, my PowerPoint is not okay. So the second area, 235 to 195. Find the difference. And next one is 195, 185. Okay, delta T. Find delta T for each area. Okay, that is delta T internal. Up to that, Ken? Need me to repeat? Huh? Which part you don't understand?
What is the 25, 25, then suddenly increase to 75.
Okay, this temperature, as I mentioned, it follows your shifted temperature.
So the TS side, T side.
Yes. The shifted temperature, where it comes from your supply temperature and target temperature. You will be given these two temperatures only. T supply, T target. Okay, to develop the PTA, you need to find shifted temperature. That is the first step. Okay, shifted temperature. How to find shifted temperature?
Plus or minus.
Cold will plus delta T min over 2. Okay, here your delta T min is 10. So delta T min over 2, 5. For cold, add 5. Hot, minus 5. Okay. Now, to arrange the heat, to arrange the temperature for the heat cascade, start with the highest. Okay, take the shifted temperature, combine all together, arrange them in decreasing order. Decreasing. So highest is 245. That's why up there 245. Okay, the highest temperature. Then here 235. 235. Lower 195. Okay. This is not the same as plotting the composite curve where you have the specific scale. No. Okay, this is based on your shifted temperature. Okay. So lowest here is 25 degrees C. So this one here, 25. Then find the delta T in between the area. Let's say here 35, 25. What is the delta T? 10, right? 10. For each area, find the delta T. Okay, up to that? Okay. Next step is to find the CP, accumulation of the CP. Now, to find the CP, here you need to show the arrow of each string. Yeah. String 1, whole string. TS25, TT185. Okay. String 1. So from 25, drag along up to 185. String 1, drag from 25 to 185. Okay. String 2, which is from 245 to 35. So from 245 up there, drag down up to 35. Similar to string 3 and string 4. Okay, now you can see the 4 strings over here. Okay, remember each string has their own CP. String 1, CP is 0.2. From the table, the above table. Not working. Okay, string 1, from the above table, CP is 0.2. String 2, CP 0.15. Okay. Now the accumulation of the CP that we need to find. Okay, I need to move to next slide. Okay, the second step just now where you need to find the energy balance, accumulation of the CP. Here, each area, you will have delta T and also the CP involved. Okay, so in this area, CP is only from string 1. Okay, the rest doesn't touch this area. So CP only string 1, which is 0.2. Only 0.2, this area. Okay, now this 0.2 is hot or cold? This one is hot or cold? Cold stream. Okay, from the equation in your slide, the accumulation of the CP, cold minus hot. Okay, cold minus hot. So this one only cold. We just take the number 0.2. Okay. Now, moving upward to this area, you have cold stream and hot stream. This CP is 0.2. Okay, this CP is 0.2. This CP, this stream, what is the value of its CP? 0.15 hot stream, right? So the total CP in this area, cold minus the hot. So 0.2 minus 0.15. What do you get? 0.05. Okay, so total CP for this area is 0.05. Okay, so to find the delta H for this area, 0.05 multiplied by the delta T here. Okay, again I repeat. To find the delta H for this area, total of CP 0.05 multiplied by delta T. Okay, delta T 75 minus 35. You will get 40, right? Multiplied by 0.05. So that is delta H for this area only. So you need to find the delta H for each area. Remember the CP cold minus hot. Because the sign later on will affect the calculation. Now let's see which one will. Okay, read here. This area. What is the CP? You have 4 streams over here. What is the total CP? This area. Cold accumulation of cold 0.2 plus 0.3 minus the hot 0.15, 0.25. What is that? 0.1. Ah, 0.1. Positive or negative? Positive. Okay, the one is total CP. Then multiply with the delta T for this area. Yeah. Huh? Delta T is 40. Yeah, delta T. Delta T 40 multiply with 0.1. Then you will get 4. 4. Delta H is 4. Positive. Okay, the positive, negative, you must take note. Later on, it will affect your the heat cascade. Okay. Now, this area, what is the CP? This area, what is the CP? Negative 0.2. Okay, negative. Cold minus hot. Then you get negative sign. Okay. The delta H. Delta H here. Delta H. Negative or positive? Negative. Negative 14, right? The sign is important here. Negative 14. Okay, means this area is giving out the heat. negative. Okay. Now, next slide, you have the table. Next slide, you have table with the internal temperature. And you should find the delta CP, the CP, delta H, and the surplus deficit. Complete that table. Complete the table for the next slide. I need to restart my PowerPoint.